Okay. Shut up. All right. So, by the way, for those of you who've never had me in class before, I'm famous for that. That was a very toned down version of shut up. So, this is your first programming class, right? How many of you are also in 175 this semester? Okay, so pay extra close attention today because some of the things we're going to be talking about is going to require something you're going to get from 175. Do let me know after class if you don't want to do the alternative, and I can get you a copy of the thing you get from 175. That'll make sense here in a few minutes. Well, let's talk about the class in general first, and then we will dive in and start talking about stuff. All right, so this is the very first programming class. We assume you've never done any computer programming before. Having said that, be prepared to spend a lot of time in this class. It's not because I'm mean, well, I am mean, but it's not just because of that. Programming is kind of like a sport. And with that in mind, how many of you play sports in here of one kind or another? All right, so I'm just going to pick a random sport. So we'll pick like, I'm a golfer. So I assume everybody in here is a golfer, a real sport, right? So I'll pick golf as an example. If you go and take a golf lesson and the teacher teaches you how to hit a 100-yard pitching wedge and he makes it look so easy, are you going to be able to hit a 100-yard pitching wedge, or are you going to be whiffing it and shanking it and doing all these things until you've done it 1,000 times, right? Okay, so you can academically understand something, but until you've actually put in the reps, you're not going to be any good at it, all right? So where computer programming maybe differentiates itself from some other academic courses is this is a skill set that you'll be applying to your entire computer science career. Now, having said that, another misnomer, a lot of folks believe that computer science is computer programming. Not a true statement. Okay, if you've had the class with Dr. Locklear, who says computer science is problem solving, that's a little boring. But effectively as computer scientists, what are we doing? We are leveraging technology to solve the problems around us, right? And God made us to be amazing problem solvers, and we solve all of our problems in terms of the tools we have available to us, right? So if you're sitting around the house and you need to fix something around the house and you have a screwdriver and some duct tape, that's the proverbial, right? You can fix anything with duct tape. You solve that problem in terms of those couple of tools that you have around, even though they might not be the best tools for the job, right? I mean, all of you in here at some point in time have fixed something with tape or something like that wasn't quite professionally done, but kind of got the job done, right? And then 15 years later, you realize, oh, that's still working. This should be the correct way of doing that. I fixed multiple doors with tape and Kleenex. Sometimes a door just won't shut right. And so you got to take the little plate thing off and you shove a bunch of Kleenex behind it and you put it back on and screw it in as tight as you can. All of a sudden it clicks better. Just did that last week to my garage door. So, So in any case, we solve all of our problems in our life, not just technology problems, in terms of the tools we have available to us. In this class, you're going to be learning about a new tool, a new weapon, okay? And in order to get good at that tool, you're going to need to practice. All right, I promise you, computer programming is an incredibly powerful tool. It will be your superpower as a computer scientist, and it will earn you a lot of money. Having said that, you will need to put in the time to get good at it. You can't just, memorize it the night before an exam and expect to come in and do well. All right. Coach isn't going to be impressed if you haven't shown up to basketball practice all season. Night before the big game, you decide that you're going to go and shoot 300 or 400 free throws, and all of a sudden you show up to the game and you're an all-star. Probably not going to happen, right? So keep that in mind when you feel that you're getting a ridiculous amount of homework. Okay, I am putting you in the position to practice this stuff outside of class. I call my assignments, we have project assignments and we also have drill assignments. Think of them as like practice where you're doing drills, all right? You're not going to like me a lot of the time. I always solve your assignments in class. You'll see that something you might have spent 5 or 6 hours on outside of class, we do in like 5 minutes in class. That's okay. That's why the golf teacher made it look so easy how they hit the pitching wedge 100 yards, and you took 3 swings before you touched the ball. That's the gap we're trying to close by the time you finish your 4-year stint here in computer science. Everybody, that makes sense to everybody? Okay, so I'm not just randomly hitting you with a zillion homework assignments because I like to see people suffer. I do, okay, but that's not the reason I'm doing it. Okay, there is something to the madness. All right, so syllabus is up on Blackboard. Grade breakdown. Each week, so at Concordia Christian University, we're supposed to incorporate a Christian worldview into the classroom. I do that anyways, but I give you free points while trying to build a good habit. Every single week you have Bible homework where you have to read. This semester we're going through the book of Luke. You will read 2 chapters per week out of Luke and write like a paragraph or a couple of sentences reflecting on it in your life. I don't care how introspective your reflection is. I am forcing you into the habit of reading the Bible every week. I'm not going to sit there and give you a 75% because you really just could have done a better job of applying this to your life. Okay? I'm not grading it like that. I want you to read it and I want you to respond to it. It's due by midnight every Sunday for the first 12 weeks. I believe there's 12 of them. All of them are up right now. I wouldn't necessarily encourage this, but if you wanted to just knock them out this week, you could. And then you don't have to remember to turn them in every Sunday. But if you do that, then I'd still encourage you to continue that habit of reading something out of the Bible every single week. Make sense? 10% of your grade. Okay? Free 10% of your grade if you just do the Bible homework. Don't be one of those students that doesn't turn those in. Never made sense to me. All right, 30% of your grade will be programming drills. You'll have you basically will have a programming assignment every class of one type or another. Programming drills will be your normal everyday. Here, this guy's going to start bugging me. Let's just do that. But in any case, those are worth 30% of your grade. Projects, also worth 30% of their grade. Idea is they're a little bit bigger. You'll probably have one project roughly every 2 weeks. Towards the end of the semester, it maybe increases a little bit. They're not drastically bigger than the drill assignments. I just kind of have separated them between drills and projects arbitrarily, let's say. There'll be 2 exams in here, a midterm and a final. The midterm exam will be roughly week 8, probably right before spring break. And then the final exam will be during final exam week. My exams are cumulative. Every exam has 10 questions on it. Probably half the exam or a little bit more will be programming. The other half will be memorizing stuff, showing me that you understand stuff. All my exams are short answer, no multiple choice, true, false, any of that junk. I have a policy. If you do better on the final exam than you did on the midterm, I'll replace what you got on the midterm exam with what you got in your final exam. I don't think one day should screw your grade over. Make sense? But at the end of the day, the end of the semester, I have to give you a grade based on how well you've mastered the material, so don't suck too many times, is the idea. So if you, the midterm I might say is more for you than for me. It lets you know where you are relative to the rest of the class. And if you come in and you get a 15% in the midterm, which happens, you can still get an A in the class. You can fix that problem with the final exam. Make sense? Okay, questions about grading stuff. Another thing I'll point out for the drill assignments and the projects, these are programming assignments. I do encourage you to work in groups if you would like. I strongly encourage you, and keep in mind me saying this now because around week 5 or 6, when people are freaking out because they haven't done half the assignments, I'm going to yell at you and say, remember when I said you should work in groups? I encourage you to set up some study groups. If a couple of you tend to be leaders like that and want to advertise that you have a study group where you get together, every Monday, Wednesday, Friday nights or something like that to get together and work on the homework and invite your peers to come and do it and you work on it as a group, that's fine. I'll find out in the exams if you're not learning. Okay, I'm not going to be sitting there looking at your homework assignments trying to decide, oh, well, so-and-so copied off so-and-so. If you turn in the same thing, that's fine. I'm not going to lose sleep over it. You're only hurting yourself, right? I'll find out on the exams. But like I said, programming is hard. Some of you might learn a lot when you see the solution in class. That's usually what happens first. Usually you understand the solution when you see it well ahead of you being able to write it on your own. Okay? So there's going to be a time period there for a while where there's going to be a gap. So sometimes working on the stuff with your peers that have a similar skill level to you or just a little bit ahead of you might help you close that gap more quickly. So I encourage you to work in groups on the programming assignments. I think it will benefit you. Take advantage of that. I'll talk about our Slack channel here in a few minutes where you can sit there and chat with different people. You can advertise your group, whatever you want on there. Okay, so I'm not looking for cheating on homework assignments. Homework assignments are practice for the big game. I tend to grade them with that in mind. Every homework assignment, specifically the programming assignments, I have something called a self-evaluation. Let me go back here. There's a template for it over here on the left-hand side of Blackboard. All right, so in that, I want you to answer 4 questions. One thing that's common with programming, I said that it's difficult, right? So you might spend 4 or 5 hours on an assignment and have very little to show for it in the end. Okay, so you turn in crap. To me, I can't tell whether you spent 5 hours or you spent 5 minutes. So how am I supposed to give you a grade based on that? Okay, so I want you to tell me 4 things. And again, if you want to lie to me, lie to me. You're only hurting yourself. I'll find out on the exams. How long did you spend on this assignment? Based on that effort, how hard you worked on it, what do you think you deserve? Based on what you actually gave me, what do you think you deserve? Then I want to know a summary of what doesn't work. First of all, that helps me zero in on where you struggled on the assignment when I'm grading it and things like that. But it also kind of takes me through your process of if you really struggle. A lot of times we learn more from our failures than we do from our successes, right? So if you tried 18 things in the process of not getting your homework done, I want to know about those things because I want to give you credit for those 18 things you tried that didn't work, even though the one thing you didn't try was what ended up being the solution. You'll find that out in class. I don't want to punish you for effort. I want to reward you for the effort. I'll find out on the exams whether you're learning this stuff. Make sense? Okay, with that in mind, no late homework because I do solve every homework assignment in class. Now, there's an emergency, hospitalization, blah, 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 family emergency. We'll deal with that in a reasonable way and figure out a way of handling it. But in general, don't come to me the day after an assignment or say, oh, I forgot to do this. Can I turn it in by Friday? Because you already have my answer after class, the actual solution to the homework. So the answer is no. So don't waste your time. So every programming assignment, every drill and project assignment, turn in this self-assessment along with it. So I have some sort of supplementary material in which to base your grade when you don't quite have a full working solution. Make sense? Okay. Questions about grading or assignments in the class? All right. Now, over here on the left-hand side, I have a link to the CUWCS Slack channel. Some of you from your 150 class may already be on our Slack channel. If you're not, some teachers have you do it, some teachers don't. You'll go to cuwcs.slack.com. This might actually just log me in because I'm already in it. But when you go to that page, it'll give you a way you put in your cuw.edu email address, and you can sign up for our Slack channel. You can download Slack as like a workplace chat type program. You can get it for your phones. You can get it for all the you can get it for all of the different platforms, so you can get your push notifications and things like that. But you can sign up for it that way. I already created a channel here, CSC200. So Once you get into Slack, you'll drop into the general channel here. So this is where we make all sorts of different announcements and things like that for things like internships or conferences or just funny things. Like here's a picture of the new classrooms, this kind of stuff. So I would highly encourage you to check Slack often. If you have it on your phones, you get push notifications just like it's a text message. So you get dumped into general by default. I strongly encourage you / cordially require you to join the 200 channel, CSC200. I would encourage you to go up here to, I think you'll do it in settings for notification preferences and set up anything in 200 to notify you. I mean, you don't want to be notified by every little thing that ever happens on Slack, so most of the notifications are turned off by default. I think the only notifications that are turned on by default is if somebody sends you a direct private message. So I would encourage you to turn it on for 200 because sometimes I'll make announcements. Sometimes students will ask questions about a homework assignment, and either I'll respond, I usually respond pretty quickly, or one of your classmates might respond with the answer, and you might want to know that there was some update or some clarification made for the assignment, that kind of stuff. Make sense? I personally heavily use Slack, and you'll have me for many classes over your 4 years, so get used to using Slack. Set up the notifications. So I will assume everybody will have Slack available to them before class on Wednesday. Doesn't cost you a dime. And I encourage you to get the app on your phone. Okay. Covered that. Okay, so let's dive into some slides here. The other thing I'll point out, you might have noticed at the beginning of class, I started this recording. I record every one of my lectures. I upload them to YouTube. So there'll be a link later on today, probably over here on the left-hand side of like streaming lectures or something. I'll also share the slide set with you. So I just give you a link and it'll be over here as well. And that updates in real time. So you'll always have access to the slides from class as well. All right. That doesn't mean don't take notes in class, but I'd rather you pay attention and interact during class than furiously copy down every word that I say. All right, make some sense? All right, so I want to talk about a couple things at the high level here. All right, so for those of you that are in 175 this semester, one of the things you're going to get in that class is something called a Raspberry Pi. How many of you have heard of a Raspberry Pi before? Okay. Not the food. All right, so it's a little mini computer thingy is what a Raspberry Pi is. And they're going to give you one in the 175 class. All right.
What if you already have one?
If you already, well, depends which one you have. They're giving you a Raspberry Pi 4, which is a quad core. They're giving you a good one. I would take the free Pi. is what I would do. And they're going to be using that heavily in several of your computer science classes. You can use the Raspberry Pi in here if you would like. It will let you fulfill what I'm going to require you to do anyways, but I'm also going to show you an alternative of running the equivalent of the Raspberry Pi in a virtual machine. Okay? So in 175, you're going to get a Raspberry Pi, which is a small computer running a version of Linux called Raspbian. All right. Now, frankly, I don't care what version of Linux you run. I'm going to mimic what you're doing in 175 with Raspbian in here. Frankly, I prefer other versions of Linux, and in my upper classes, I use a different version of Linux, but just so you see identical to what you'll see in 175 and what you'll see on your Raspberry Pi, I'll use Raspbian in here. So you can either, and I do require you to do all your programming assignments in Linux in here. So let me jump to another slide here. How many of you have heard of Linux before? All right, what is Linux?
It's an open source open source operating system.
Okay, it's an operating system. So it's kind of like Windows, kind of like Mac OS, but it's not those, right? It's another one. Now, how many of you have used Microsoft Windows? Every hand. How many of you have used Mac OS? Fewer hands, but many hands, right? Okay. You're not allowed to use those in this class for your homework. Why do you think that is? Again, because I want you to suffer. First of all, Linux is the better operating system. Now, having said that, I'm a Mac user. But one of the reasons I like Mac, I grew up using Linux, is Mac is, at some point I'm going to tell this story, but long story short, Apple built their new operating system on top of an operating system called NextOS, which is based on Unix. So actually, the Mac OS today is a Unix operating system with kind of a pretty front end, let's say. Makes it look nicer. But it's still effectively, it's actually based on top of an operating system called OpenBSD Unix. So Unix, Linux, let's just call them basically the same thing. Unix was closed source. Linux is open source. Whatever. At some point, we'll get into the details there. But Linux, Unix, synonyms for each other. It's a different operating system than you're probably used to using. All right. Now, we're computer scientists in here. Computer scientists don't sit there and use the easy-to-use operating systems that grandma uses, right? We need a powerful tool, and we want to gain an appreciation for how these tools are more powerful. We're going to spend a lot of our time out at the terminal writing regular expressions and things like this, things that allow us to really use our operating system, get stuff out of it rather than just double-clicking icons and that kind of junk. All right, and that's going to be a theme throughout all the classes, hopefully all the classes you have in computer science, but definitely the classes you have with me. We'll be doing a lot of stuff on Linux, if for no other reason than forcing you to use the operating system or an operating system that you don't use every single day. Make sense? Go ahead.
So can you do Linux in Windows?
Yep, that's what I'm going to show you to do. All right, so having said that, two options. So we're going to be using a distribution of Linux called Raspbian. So for instance, when I say what's your favorite operating system, a lot of you would say Windows 10, right? Windows 10 is not actually an operating system. Windows 10 is a distribution. Does anybody know what the operating system that Windows 10 runs on top of is called? It's called the NT kernel. The NT kernel, New Technology Kernel. Kernel being K-E-R-N-E-L. Okay, that's the core operating system, is the kernel, and then the distribution is the thing that makes that usable. Because as human beings, we like pretty buttons and windows and the button that says start. We like all that stuff, right? That's the distribution. Also, when you first install Windows and the Mac OS, it comes with some other things, right? It comes with a web browser, it comes with a text editor, and blah, blah, blah. That's part of the distribution of that operating system, okay? So we're going to be using a Linux distribution in here called Raspbian, which is the same as the Raspberry Pi uses, okay? Now, if you were to pick an alternative version of Linux, if you wanted to not necessarily challenge yourself, but maybe a more, let's call it professional while still easy to use distribution of Linux, you might pick Ubuntu. I would go with 1804, which is their latest stable version. There is a 19-something version of Ubuntu, which is fine. Life will go on. But if you want to not have too much experimental stuff on there, get the 1804 things. I have both of them on my machine. Again, this kind of goes what you were asking. Can you run it inside of your operating system? I'll talk about that here in a minute. But if you wanted to use something other than Raspbian, you can use Ubuntu. Other popular ones, Red Hat is enterprise now. So Fedora, Slackware, Debian. Actually, Ubuntu is built on top of Debian. So you have the Linux kernel, And then you have a distribution of Linux called Debian. And then you have Ubuntu that said, hey, we want to make Linux easier to use for the masses. All of that's built on top of the actual Linux operating system. So I don't care which of these you pick, it's Linux. Linux is the kernel. It's the Linux kernel that's running on top of. That's what's most important in here. If you want to mimic what you'll be seeing in 175, use Raspbian. That's what I'll be doing in class when I show examples. But if you wanted to pick a different one and find your own software and things like that, feel free. The things I show you here with Raspbian in terms of getting it on your machine, you could do the identical thing with Ubuntu. So maybe you start with Raspbian and you decide, oh, I'm going to switch teams now because I can't find enough good examples of extra fun things to do online for Raspbian. You probably will because Raspberry Pis are pretty popular, but you'll find lots and lots and lots of common examples for Ubuntu stuff when you're trying to get into Linux and learn about some of that stuff. A lot of the examples for some of the other distributions like Debian or Fedora, Slackware, they're going to be a lot more dated. You might find stuff from like 2002, things like that. Probably will still work, but if you're just getting into Linux, I would use Raspbian or Ubuntu. My recommendation for you in here is Raspbian. Okay? And I do give you a link over here on the left, Raspbian image for VirtualBox. So this will allow you to download an ISO image of the Raspbian distribution of Linux. Now, why do you need to get something special for Raspbian? So Raspbian is an operating system it's a distribution of Linux built to run on the Raspberry Pi. The Raspberry Pi is a relatively low-powered computer, right? Even though the ones we're going to be giving you in 175 are quad-core Raspberry Pis, pretty solid machines. Not going to be as good as the machine you have at home, but, well, it better not be as good as the machine you have at home. Some of you might be replacing. Like, well, you know, I got a worn-out power button or something, so who knows? But it's meant to run on relatively low-powered hardware. And the processors that are running inside of Raspberry Pis are a type of processor called an ARM processor, ARM. So it's something that's different than like an Intel processor that you have sitting inside of your laptops. They're solving the same problem, but it's a different approach to the same job. So the Linux kernel compiled for, and all these things will make sense once we get farther into this class, we talk about compilers and things. Compiled for ARM is not necessarily identical to the Linux kernel compiled for Intel open architecture. But your laptops or your desktop in your dorm room or whatever is very, very, very likely running an Intel or an AMD processor, an Intel compatible processor, some, you know, Core i5, Core i7, AMD, something or other. So these are all Intel compatible processors. So this Raspbian image I gave you is for those. All right. And then there is a tool released by Oracle called VirtualBox. That is a virtual machine that will allow you to, inside of your current host OS, whether it's Mac OS or it's Windows, to install VirtualBox, which will allow you to use your own hardware to drive another operating system inside of your current operating system. For instance, there's Ubuntu. Oh, it didn't pop up on there? Oh, it did. It did pop up on there. All right, so here's Ubuntu on here. If I click over here, I just put Ubuntu to sleep. I'll go ahead and launch Raspbian. And there's Raspbian OS running inside of on my Mac. Okay. Now, I'm running this inside of a competitor to VirtualBox called Parallels. They're all the same. Parallels integrates with the Mac a little bit better, let's say, and I do a lot of virtualization stuff, but Parallels cost something, VirtualBox does not. Choose your poison. But it'll let you accomplish the same thing. First of all, notice I probably can make it take up more of the screen, but with Raspbian, once you have Raspbian running for the first time, you'll see that your interface will look just like this. So you have the little, this is your start button, the little Raspberry up there. You know, just like a Windows E type thing, right? And it already has some stuff installed in there, particularly for us. It has a programming thing, and we're going to be using something called their Python IDE, which comes with it, because we're going to be using Python in here as our example programming language. All right, so what do I mean by example programming language? So let me go back here. We'll make a little statement. Programming is a skill set. The language does not matter. All right? What does that ultimately mean? Let's work backwards here, then we'll come back to this statement. How do humans solve problems? We talked earlier about how we solve problems in terms of the tools we have available to us, but if we have to start with the level below that, like we're our own starting point. We're the ones who pick up tools. That's what sets us apart from the animals and things like that. So, you know, we solve problems in terms of the tools that we have available to us, but what internal inbuilt tools do we use to solve our problems? So we use our memory, we ask questions, and we do repetition. All right, first day of class, as in today, I always ask, how many of you got to class today without bumping into any walls? You usually get a couple of smart asses that say, oh, yeah, whatever. But if you walk in the halls, what do you see? You see crowds of people all on their smartphone, right? Texting, bobbing and weaving out of the crowds, not bumping into any walls, not even paying attention to what they're doing. How hard is walking? Could you describe to me in detail how to walk? Every little muscle that has to fire, the whole thing of not falling over, like, you know, falling left, falling right, you know, tense the calf muscle, whatever, all these things. Walking is a very, very, very complex task, right? Yet it's not worth our full attention. We'd rather text while we're doing it because we can make it. We can make it without falling over, right? All right, so human beings, well, here, I'm going to throw another slide in here. Why is programming hard? Many, 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 many people who come into technology majors choose to go to IT instead of computer science because they think IT means not programming. Not a true statement, first of all. Okay? But a lot of people leave technology majors because programming is too hard. The reality is it's not that programming is too hard. Why do we find it difficult? It's humans are so good at solving problems that we have difficulty articulating how we solve them. This is a really important concept here. In order for us to tell a computer what to do, we have to give every tiny little baby step to how to solve a problem. All the things that we walk down the hall bobbing and weaving out of people while texting. It wasn't worth our full attention to do something that would be pretty much impossible for any of us to describe in detail how you walk. Yet it's something we take for granted. If we're telling a computer what to do, we're the boss, right? We have this tool, a computer, and we have the thing that lives between us and the computer, the programming language that allows us to boss this guy around. And we have to tell the computer how to solve problems. In order to do that, computers are dumb, right? They're not going to fill in the gaps. It's not like talking to another human being. You're inviting somebody to a party. You're saying, you know where Caribou is? Kind of go there, then turn right at that main street. I don't remember the name of it. And I think we're like 3 or 4 blocks down. It'll be the second light. Turn right there. A human being can follow instructions like that and probably get to your house, right? A computer can't. You need to be completely unambiguous with a computer. So what human beings suck at is slowing our mind down and breaking problems down into their individual little baby steps. Okay? We don't even like looking at instructions like that. How many of you have ever followed a recipe while cooking? I assume most of you just didn't want to raise your hand, right, at some point. But we don't even have the patience usually for the recipes, right? How many of you have ever skipped steps in recipes and realized in the end it didn't taste right? It's like, oh, I left that whole section out, right? Because you just kind of skim it. Or you were doing something with baking and it didn't rise because you left like the main thing out, right? It's like, wow, this was more just, you know, these instructions weren't all that important, right? It was more of a recipe is an algorithm. It's the set of unambiguous instructions that you need to follow step by step by step by step by step to hopefully get a finished product in the end. Now, the difference there is that a recipe is meant to be read by a human being. So we can rely on that human being to fill in a little bit of gap, right? You know, when you say a pinch of salt, we can just let a human being decide what a pinch is. You know, use some tomato sauce. We can let the human being kind of decide on which sauce they should buy or whatever, or maybe to substitute, you know, a dairy-free option for something else that's in there. You know, human beings are going to fill in some gaps because we're smart. We don't have that luxury with computers. We're writing recipes for computers that have to literally tell every little tiny baby step that has to be taken. That make sense? That's hard for human beings to do. Because we're so used to, we spent 20 years of our lives here communicating with other human beings. We're really, really, really good at talking to people. We're not so great at talking to computers. In fact, even the experts at programming are going to be limited on what we're capable of telling a computer what to do. So we used the example of walking a little bit ago, and we could all agree that walking is so complex that it would be, let's just call it for the sake of argument, impossible for a human being to fully articulate the complete instructions, the complete recipe for walking. We kind of figured it out, right? As babies, we got up and fell down, we got up and fell down, and all of a sudden we got up and almost fell down but didn't. And then next thing you know, we're mobile. Next thing you know, we're throwing things, breaking things, whatever, but we figured it out. We don't know how, it just happened, right? So we're going to say it's impossible for us to articulate something that difficult. How many of you play video games or have ever played a video game in here? A lot of us, right? Which do you think is harder? Which is the harder problem to solve? Walking, or pick your most impressive looking video game, Battlefield XYZ with explosions, all these things? Which do you think would be harder to tell somebody how to solve that problem? Walking. Those video games are trivial compared to walking. That's kind of like as hard as we're able to get as computer programmers telling a computer what to do. How many of you have heard of artificial intelligence? Machine learning. Heard some of those words? Okay. What is machine learning? Anybody know what that actually is? So as computer programmers, we're starting to hit the limit of what we can actually directly tell a computer what to do. So now what we're trying to do is we're trying to mimic the way human beings learn through modeling the human brain in software and saying, okay, well, we're going to build a miniature version of the brain, very simplified version of it. And then we're going to feed it stuff and let it figure it out. Here's an example. My first experience with machine learning was a couple of minutes ago when I was in grad school. And we wrote a neural network for the multiplications table. And we created a model of the brain. Forget about the details of that. We created a model of the brain in software. And we gave it flashcards of the 1 through 5s table. And just kept feeding it the 1 through 5s table over and over. And the thing was just making guesses, right? It'd be similar to like you giving a quiz to your dog, right? How many barks is the number, whatever. And then, but you wouldn't do this to your dog. But, what you do is when the neural network gets it wrong, you slap it on the wrist. You tweak it a little bit. You make a couple of little variable adjustments. You feed it the next flashcard. And over hundreds of thousands or even millions of flashcards, and the subsequent beatings, you finally like tuned this neural network to get all of the 1 through 5's table right. You know, you just have these numbers, all these different synapses and the values associated with it are just balanced just right that you can feed it any value in the 1 through 5's table and it guesses the right answer. But then what was fascinating, the punchline is then you feed it the 6 through 10's table, data it's never seen before. And it got like 97% of them right. So you taught this model of the brain the pattern of multiplication without actually telling it how to do math. Does that make sense? That's what machine learning is. We're saying, hey, we've kind of reached the limit of what a human being can describe in detail to a computer. So instead, I mean, we could tell a computer how to do multiplication, but you imagine larger problems like, you know, automated driving, cars driving themselves, things like that. These are things that human beings are very good at, making real-time decisions, but computers can get all sorts of data, way more data than a human being can process. But what it does to that data might be more difficult. Can't make the decisions that a human being can make. So with this in mind, we're applying neural networks to problems like that. How do we train a car, a computer, for driving a car to drive at least as well as a human being does? Something along those lines. That make some sense? Okay. So programming is hard because human beings, and we're out at 55, right? Okay. So programming is hard because human beings are so good at solving problems that we can't slow things down. So one of the things that we're going to have to overcome in here as beginning programmers is how do we slow our brains down to articulate every little tiny step to tell a computer what to do. I promise you, that is what is the hard part of programming, not the language itself, whether we're doing Python or C or C++ or Java or C# or Swift. Doesn't matter. The languages are all the same. I'll connect the dots here. How do human beings solve problems? We remember things. We ask a lot of questions, so many questions that we've forgotten we asked them, right? So as we were going down the hall texting, we were constantly saying, am I going to fall over to the left? Am I going to fall over to the right? Am I going to hit something? I'm going to hit something. I'm going to hit something. We know we're asking those questions. That's how we're bobbing and weaving in and out of there. We know we're glancing up every now and then, right? And we know we're asking these questions, but we don't hear ourselves asking them. We drive ourselves crazy if we did. But we know we're asking them, right? We're just so good at solving that problem that we can kind of silently ask. All right, and then we do a lot of repetition. So I have a slide here that I call the mapping. 100% of programming languages have facilities for these three things. Memory is usually done through something called variables. Asking questions is usually done through conditionals. A lot of times this is if statements. Repetition is done through loops, functions, things like this. 100% of programming languages will have facilities for these three things. So if you understand how to program, you understand the skill set of programming, and I introduce a brand new language that you've never seen before, and I say this is how you define a variable, this is how you ask a question, this is how you write a loop. You can now solve a big subset of problems with that language in 5 minutes. So that's something that we do throughout our program, is we keep switching languages on you. You'll be working with Python, you'll be working with C#, with Java, with C++, with C, with a little bit with Swift. We do some iOS stuff, with a language called Scheme, which is a superset of Lisp. All right, so in any case, 100% of programming languages will have these mappings. The language doesn't matter. We're picking Python as our first language because A, it's an industry standard language. It's very popular in industry. Throwing it on your resume will benefit you. Now you know how to do this, blah, blah, blah. And it's as good of a language as any. Having said that, there is already an assignment up. Actually, I have all the assignments up for the entire semester. You can get ahead if you want. I would suggest you go at the pace of the class, but do whatever you like. So you have a drill assignment that is due. This one's due on Friday, though, just to kind of get us into the semester. 1-page paper on SQL. We're going to be talking about a lot of history programming stuff the first week or so. So this is like the filler for that. So write a 1-page paper on SQL and what role it plays in modern programming. So for Wednesday, get your Slack channel set up. I would encourage you to download VirtualBox, download the Raspbian image, get Raspbian running on your laptop. I have a install Raspbian on VirtualBox video I gave you up here. So go ahead and click on that and follow that. I'm probably forgetting something, but let's just leave it at that for now. So questions, comments, concerns, bribes. I will see everybody on Wednesday.